Hi guys, welcome to the last week of this OMK 2015 Muda discussion. So in this week we'll be discussing about soalan 3, which is unarguably the hardest question on this competition, on this paper, because one, it might take a long time to do, and then two, most of us are stuck with it. So okay, so let's take a look at what this question tells us. I'll show the English part. So four positive integers are given, and then all possible pairs of numbers are formed as 6 pairs, and the highest common factor of each pair is calculated. 6 different numbers are obtained. So notice here different. 1, 2, 3, 4, 5, and k, and determine with proof the least possible value of k. So maybe one thing that we might want to do is to draw maybe 4 circles in which we will indicate the numbers, and then draw 6 lines like this. So drawing 6 lines, on each line we will indicate the HCF of each number. Then maybe most of us don't know or what to put. Maybe should we put 1 first? Should we put 2 first? I don't know, but okay. Here is a very, very important observation to make, so jot this down. Look at 1, 2, 3, 4, and 5. So looks like very innocent numbers, right? You don't know anything with them, they don't know anything about you, blah. Okay, but look at 2 and 4. 2 and 4 have a highest common factor. By the way, if you don't know what a highest common factor is, I recommend you looking up the web. 2 and 4 have a highest common factor of 2, which is larger than 1. So okay, so maybe I say I'll put my 2 here. So should I put my 4 over here? What happens if I put my 4 over here? So what will happen is that how should I say? What happens is that all of the 4 numbers will be multiples of 2, which does not fulfill these standards 1, 3, and 5. So no, we cannot put our 4 over here. So our 4 should be put somewhere else, maybe here, right? So okay, here is a very important observation to make. So let's write it down. Okay, observation. From this wait, 2 and 4, wait, 4 have a HCF larger than 1. So there are 3 even numbers and 1 odd number. Okay, so this is the most important thing to do. And then for the odd number, maybe we say this one. Okay, so maybe this one is 1, maybe this one is 3, maybe this one has a relation of 5. I don't know which is which, but okay, it goes along the lines of these. And then okay, since this odd number has 1, has 3, and 5, so this one should be a multiple of 15, right? The LCM, lowest common multiple of 3 and 5, is 15. But it cannot be 30, it cannot be 60, it can be 15, 45, 75, and so on and so forth. But okay, so let's say for this circle we will put a 2a, and then for this circle we put a 4b, and then for the other circle we put a 4c. Okay, so this a is an odd number, right? So what we will have to write now is that okay, so maybe a second observation. So second observation, the remaining HCF, the unknown one, K, cannot be a multiple of 4. Instead, it is in the form of 4m plus 2, where m is an integer. Okay. So going back to the question, because this relationship of 2a and 4c is a form of 4m plus 2, so what should we do first? We will have to try one by one, to be honest, to find the least possible value of k. So maybe we try, okay, let me draw another text box. Okay. A big one. How big should it be? I also don't know it. Okay. So maybe if our m equals to 1, then our k would be 6. But look at if so what does this mean again? Okay, so there is this 15, okay, and then our 4c are all multiples of 3. Since there are since 6 itself is a multiple of 3, but this should imply that there are 3 HCFs of multiples of 3. But, okay, so this is the exciting part, but there are only 2. So, contradiction. Contradiction meaning opposing what you originally intended or what you originally said. So, k cannot be 6. Okay, then we'll try the second smallest one. If the smallest one we can't do, so maybe if m equals to 2, then k would be 10. So what do we have here? Okay, so we have this 15, 2a, 4c are all multiples of 5, and then since 10 itself is also a multiple of 5, wait, but okay, so this is also the same thing as above. So there are 3 HCFs of multiples of 5, but there are only 2. Hence, wait, hence, contradiction again. So we have just seen that this 6k equals to 6 and k equals to 10 are both not possible because we have this, how should I say, let me draw something. We have this 5, we have this 3, and then if there are 3 multiples of 3 or 5, then there should be also 3 HCFs, which are, how should I say, which are also multiples of 3 and 5, but we don't have, so it's impossible. So now we go to our last text box, I suppose. I don't know how long how big I should extend this text box. Hey, where's my stuff? What's this? Oh, okay. Wait, so this is a technical problem. Okay, so now we try m equals to 3 and then k equals to 14. So this is actually possible. Now what we want to do is we draw this circular thing, and then we prove that such a configuration exists, and then we're done. Okay, so maybe for this odd number we'll put 15. Okay, and then so maybe this has a relation of 2 and then 4 and then 14. Then we have a relation of 5. Wait, what do we have here? 1 and then what's that, 3? Okay, so this is a 3 So we have 24 and 140, and then maybe a, what should I say, 14. Okay, so we look pairwise. Okay, so 15 and 14, the LCM is 1. 14 and 24, the LCM is 2. Then 15 and 24, LCM is 3. 24, 140, LCM is 4. 15, 140, LCM is 5. And then the last one, 14 and 140, the LCM is 40. So because such a configuration exists, so I think we should be done. So we should be done. So with proof, with our written proof over here, so this is our written proof. This is our written proof. We have proven that the least possible value of k is 14. So yeah, QED, we are done. But the most important takeaway from this session is to look at maybe minor observations that maybe you might find very minuscule, very maybe not so important. Actually, they are very important tools in helping us, because me myself, I thought for over half an hour regarding this problem. So yeah, so if you guys are going to participate OMK in the coming years, I hope that you can take the time to slow down, not give yourself so much anxiety, and then to maybe for these kinds of questions, just slow down and observe, because this is what a mathematician does, observing the world. So hope you guys had a great lesson. I don't know if it's great. Just maybe comment down below, and we will see you next week. So bye.